Hello everybody, my name is Tiffany Bouchara. I'm an associate professor working at l'UQNAM in Paris, and I'm also working with Nicolas Miseris, researcher at ICAD, still in Paris. Together we actually studied the mental representation, also called mental models, that underlie the conception and the interpretation of sonic icons. Our project began with the objective to make mobile apps more accessible to everybody, even foreigners or migrants speaking another language, and even people suffering of illiteracy or digital illiteracy. As you can see here as an example, we have this health insurance mobile app, and you can see that there is still a lot of visual icons and still a lot of text, so it's very difficult to understand for people not able to read this language. Plus, it has already been proved that visual icon interpretation is influenced by sociocultural origins. So our idea was to design sonic icons so we can facilitate and maybe disambiguize the understanding of visual icons and functionalities. As you have noticed, we talk here about sonic icons, not ear cones or auditory icons, not spear cones or morphocones and so on. We actually use the term sonic icons to englobe all types of sonified symbolism. To obtain a better design and more easy to understand, it was necessary to employ a user-centered approach and then take the mental representation of the users into account. Problem is, we don't know yet in the ICAD community if there are some sonic invariants that already exist across users or even across the sound designers themselves. And then the question will be, will the icons be perceived the same way by all users, even coming from different cultures? Before we can actually answer that question, we were more about crossing designers and crossing users. Very few papers have studied this question. There are very few papers about just sharing interpretation of sounds from people coming from different cultures. For example, there is this study from Langlois and colleagues comparing the perception of auditory alarms by users coming from 6 different countries, and there is this Gian and colleagues study comparing emotional integration of some affective icons. However, for both these studies, the sounds were designed by only one designer and then compared by or interpreted by several users. We could also find only one study comparing users and the designer interpretation, and in that study from Jumeva, the participants involved were actually several naive participants and only one expert sound designer, and the sound designer was not the one designing the sounds for the experiment. So there is still a question about a possible shared conceptual model across designers. To answer that question and also test the idea of invariance across users, we developed a study composed of 2 distinct phases. One to ask several designers to design sound for the same functionalities, so we can compare their design processes and also the renderings. And another phase to evaluate the obtained sounds by naive listeners. So concerning the first phase, about designing sounds by several designers for the same functionalities, we needed some functionalities to sonify, so we first selected 4 different applications for 4 different public services, and we listed every visual icons associated with the different functionalities in these apps for every views of the apps, for every pages of the apps. And then we look for some similarities inside them for mobile apps, and we found some of them, like the professional directory. It's when a user look for a specialist, like a doctor, or this document function when you want to see some PDF files in your account. We actually kept 12 common functionalities that appear in at least 3 of the different mobile apps. And we asked 13 students coming from 2 different schools of sound design to design 1 sound per functionality. So they had to design 12 sounds each. And to have an insight on their design processes, we also asked them to make another textual document to document their intention and their design process. We also had a problem with the WAP and WAP function. Actually, we designed or imagined it was only one function, but for some students, not all of them, but for some students it was 2 different functions, so they designed 2 different sound files. At the end it was too inconvenient to use this 1 sound file for some students or 2 sound files for others, so we removed this function, and we kept only 11 functionalities coming from 13 designers, so we had a total entire set of 144 sonic icons at the end. You can find the entire set on this web page, and I just want you to listen a little bit. For example, on one sound designer, 11 function for this sound designer D. This was the set. Now we have a set of 144 sounds. The idea was to evaluate the set and maybe identify if it was correctly done, for example, and it is possible to understand it. And also it was this second phase was to compare different interpretation coming from different potential users. To do so, we use a free classification task, but as the set contains too many icons, it was too long to label, of course, but it was also too long to classify the entire set. So we decided to ask the participants to sort only one part of the set. So every participant sort only 44 icons, so the 11 function for 4 designers. And then to be sure that every icons were evaluated the exact same number of times, we had to involve a lot of participants. So we involved 54 participants actually. We used TESEL Labix for the classification task, so every sounds can be listened by double-clicking on it, and then participants had to drag and drop the sounds on the surface to group the sounds in different groups. The number of groups was not specified. Once the classification or the grouping has been done, participants had to label each group like that, so they had to click on every sound of a group, and then they can just label it with very few words. For example, here it's home, according to this participant. So for the analysis now, we grouped the different sounds inside groups, and we wanted to see if the grouping is the same for every participant. So we make a co-occurrence matrix, principally because every participant doesn't have the entire set to cluster, to group or classify. So we have this co-occurrence matrix, and we made a cluster analysis, so we can find a certain number of categories. We impose 11 categories with this co-occurrence matrix. We found these categories, and what is interesting is for some of these categories, for example, if we zoom on this one, we can see that, still zooming, we can see that all the function 7 sounds, so the sounds that were supposed to be designed for documents, were all grouped inside this category. And we can find actually 2 different categories with the same analysis. The scan function was designed the same way by and interpreted the same way by 7 designers. So this was the sound for the scan. Just listen to it. And all these sounds are based on the same metaphor about a camera to take photographs for scanning. And for the document is the same. There is a very shared mental model here about a paper and pencil metaphor. So for 8 of the designers, actually 11 of them, but I could take only 8 sounds for this slide. 11 designers design the document function the same way, with the same metaphor. To conclude, this was an original approach with experts and designers and naive auditory users both combined in the same experiment. But still we have a lot of work to analyze correctly this or data, the obtained data. And maybe to reduce the noisy data we have, it would be much more comfortable to make a new experiment with pre-selected but promising functionalities. After all, the last question about different cultures and invariance across cultures is still to answer. Thank you very much. Maybe you have some question?
Great. Thank you, Tiffany. I believe there's already a discussion going on in the Q&A about the strategies employed. Do you want to jump in and discuss something about it?
Yeah, sure. Just to answer Bruce, actually, we analyzed the reporting the designers made about their own designs processes, and we found that they use only ear cones and auditory icons, and sometimes hybrid mixed auditory and ear cones design. They never use peer cones or voice, never, but they rapidly choose a sound source to design the sounds, something that's may cover the how to say that, yeah, a sound source that evoke the functionality. So the example with camera and scan was the major findings we had, but a lot of sounds were also ear cones, and it was very difficult for the participants to, in the second phase, to classify these ear cone sounds associated with something else. It was, yeah, mainly short, so the duration of the sounds that makes them classify the ear cone. So it was very difficult.
There's also another question about the disagreement amongst responders. If you have a quick.
Yeah, about the ear cones is. Ear cones is typically a grammar, so without the context, it's very difficult. In our experiments, we try to classify the sonic icons without any context, so it was kind of difficult for the participants to imagine a functionality with that. So sometimes they just associate sounds that sound the same, but it was not about the functionality except for the sounds that were actually auditory icons, or using real sounds.
That is great. I think you might want to revisit this discussion in the Q&A room during the break.
Yeah, sure.
On behalf of everyone, thank you very much, Tiffany, for joining.
Yeah, I just want to conclude that we won't be very available with Nicola at the break. So if you want really to ask people some question in live, we will be very happy to make another appointment somewhere else.
Let's not forget that we have Discord for that. So you could
sure.
send a message to Tiffany via Discord and people can follow that discussion.
Yeah, thank you very much for the question, and thank you, Arete, for the organization.
Thank you very much, Tiffany.